Good afternoon, everybody. My name is Pinky Loomba. I'm a real estate investor and a blockchain enthusiast. We are here once again with our guest speaker, Omar Syed. Over the past 3 decades, Omar has been involved with helping large organizations such as NASA, Yahoo, and Zynga to build scalable, fault-tolerant distributed systems for mission-critical applications. Omar has also been involved with several startups, including the first matrimonial website and the first stock sentiment analysis website. In early 2016, he started Unblocked Inc., a blockchain consultancy company. In 2017, he organized the Sharding project to build a linearly scalable blockchain. And today we're going to be talking about the Sharding project. Today, we're going to be talking about the Sharding project. How did you come up with an idea to put this project on blockchain?
So basically, Sharding got started because we saw that there was a need for applications that needed blockchains that could, scale to really, really high numbers. So at some point, maybe we could talk about Bitcoin, which basically is a cryptocurrency type system which gives like a universal basic income to every individual that has an account on the system. And as we were thinking about how to implement that, we realized that with the current blockchain technology, we could not actually implement it. And so then we started thinking about, well, how do we design a blockchain that could be able to scale up to handling, like say millions of transactions per second and handling, potentially every person in the world having an account on that system. So that kind of led us to starting Sharding.
Before Sharding, you had this Unblocked, right? That's what the name of the last company was. So that was something related to blockchain as well?
Right, and that was basically just doing some consulting work for some companies in Dallas that were trying to get started in the blockchain space.
Before the recording, you were talking about linear scaling. So what is linear scaling and how or what you're trying to do with this Sharding project regarding linear scaling?
Right, so that's one of the unique things about Sharding, which is different than most of the other blockchains that are out there. So Sharding is designed to linearly scale, which basically means that as more nodes are added to the network can actually have more transactions per second. So like, current blockchains, like Bitcoin or Ethereum, I think Bitcoin gets like about 5 transactions per second and Ethereum is like 20 transactions per second. And the reason for that is because in these networks, every single node has to, validate and process every single transaction. And so it doesn't matter if you have 100 nodes in the Bitcoin network or 1,000 nodes in the Bitcoin network, it's not going to process any more transactions. So that's where, with Sharding, we use a technology called sharding. And basically what sharding does is it divides the nodes that you have in your network into smaller groups, and transactions then are routed to the appropriate shard, which can handle that transaction. And so only, so nodes only have to process the transactions that, are relevant to them and not every single transaction. And so you get, parallel processing proportional to the number of shards in your network.
So sharding means it's like more like a distributed system. When you say you create a group of nodes, so it's just like, to me, for one to understand in the computer language, you're trying to distribute the processing power. So like more nodes are joining, but they're like in a group kind of format to mitigate the time lag. Is that a true statement?
Yeah, absolutely. So we're, taking the big network that may have, say 1,000 nodes in it, and creating smaller groups of nodes within that network. And so now we get more parallel processing. So blockchains are, by default, like distributed systems, because, there's a lot of different nodes, each one independently holding redundant data. So that makes it distributed. But what, the other thing that you want in a blockchain is decentralization. And then now this, third thing that we're adding is parallel processing, in a blockchain. So.
Okay, so let me ask you this question. On blockchain, to me, blockchain is a big ledger or a hyper ledger, I would call it. So, and then you said that there are distributed systems or DApps people are developing, and then you're adding this linear scaling concept or the grouping the nodes and therefore the better processing. So I wanted to understand that Shardus, how does Shardus fit into this blockchain? Is it like a separate private ledger, or is like an open source? Like blockchain is open source, anybody can develop any app.
Yeah, so I mean, Shardus is different than like these smart contract platforms. So a lot of people are very familiar with the concept of things like Ethereum, where, it's a big network that allows smart contracts to be created on the network, and people can interact using, like some web browser or something with those smart contracts. Now, with Shardus, what we're really building is the core software that you need to be able to launch your own network. And we don't define what the application layer is going to be. So somebody can basically take the Shardus software, write their own code for the application layer, and then start, deploying these nodes to then create their own application-specific decentralized network.
But
So
it's going to be part of the public blockchain, right? It's not a private, since being is on the Shardus platform.
Well, depends on, how whoever, built that application layer, what they want to use it for, right? So for example, if, somebody wants to create like a decentralized Reddit, that would be a public network, but Shardus could also be used to create like a private network, which is used between companies, right? Like, let's say you have a big company and they want to track all the, things that are shipped from their suppliers and so forth. And so they could use it in a private setting as well.
And then there's going to be own nodes, their own computers that's going to be validating all the information.
Yeah, exactly. Yeah.
So it's a private ledger sitting on the hyperledger. And when they choose to make it public, they can do that too, right?
Yeah, so the hyperledger is not really involved here, but you can basically think of Shardus as a product that's similar to hyperledger. It's Shardus doesn't use hyperledger at all. But it's a product that's similar to hyperledger in that it allows you to define your own application and then be able to launch your own, decentralized network.
So can you tell us the difference between the Hyperledger and the Sharding ledger? Like you said, it could be private and public both. So what is the main differentiating thing?
Yeah, so it's basically, like kind of saying what's the difference between the Oracle database and Microsoft's database, right? They'll have like little differences in the features, but so in our case, I think some of the key differences between Hyperledger and Sharding is, of course, Sharding is using sharding technology, and
Right.
Hyperledger doesn't use that.
Mhm.
Also, Hyperledger, I think the framework that they use for building that, I think you might have to program that in C. Whereas, with Sharding, we've developed it in Node.js. So our application developers, they can just develop it as if they're writing a Node.js backend for a website, for example, right? Just create the APIs and then have their application level software handle those APIs, but then you let Sharding take care of distributing those transactions throughout the network, handling things like consensus and nodes joining, leaving the network, and keeping the whole network synchronized. So yeah, so I think that's primarily the difference, and also Hyperledger wasn't really designed to scale to very, very large networks, whereas with Sharding, we can go to thousands of nodes. I think Hyperledger works better when you have a smaller number of nodes, like maybe around 20 or 30 nodes.
That's about it.
Mm-hmm.
Wow. So is it like application centric?
Yeah, so Sharding is kind of application agnostic. I mean, it doesn't care what application you want to build with it, right? So just like a database, it doesn't care whether you use the database for an e-commerce website or you use it inside of your company to, manage your customer data. In the same way, Sharding doesn't care what kind of application you're using it for. We haven't defined any like application specific features into Sharding.
And the other terminology I came across was the D apps. So what exactly is the D apps? Is it like decentralized apps?
Yeah, so DApp is just another word for decentralized application. Now, typically, that DApp phrase or word is used a lot with these smart contract platforms like Ethereum and Binance Smart Chain and so forth. And it basically defines a particular application that's running on a smart contract platform, and it may also include like the software that you use to interact with that application.
But you said Sharding does not need the smart contracts.
Right. So with Sharding, you're building a dedicated application where the whole network is for that one application. Right. So like a smart contract platform, you can think of it as a lot of, shared resources, right? Lot of different DApps are sharing the same Ethereum network, for example. With Sharding, it's like you have the whole network just for your one application. And so, in the future, I think there's going to be a lot more decentralized applications that people will want to build where, the number of transactions these applications need will be like in the tens of thousands of transactions per second. And right now, even the best decentralized, smart contract platform doesn't handle anywhere near that many transactions, right? So like, for example, if like on Ethereum, there's only 20 transactions per second, and that is shared among all of the different smart contracts that are on that platform, which is why, you know, it's getting really, really expensive if you want to do any kind of transactions on that network.
Mm. So can you tell us what is smart contract? Because you use the word smart contract multiple times in the conversation. So is it like a contract like we write in today's date, maybe 10 pages, 100 pages, 200 pages contract? What does this contract look like on blockchain?
Yeah, so a smart contract is really a contract defined in terms of software. You know, like we're used to contracts being like, you know, written documents that are written in English, but smart contracts are basically programs, and they carry out what kind of interactions the different parties involved can do, right? Okay, so for example, you can, let's say you can use a smart contract to create something like a Kickstarter, right? Or a GoFundMe, but without needing a third party to be the middleman to you know, handle those payments between the people who want to donate and the person who's launching this project, right? So for, you know, like with Kickstarter, somebody says, hey, you know, I want to build this thing. I need $1 million. You can donate to my project, and you know, if it reaches $1 million in 1 month, then I get that fund, and then I go off and build, you know, whatever I'm trying to build. Otherwise, if it doesn't hit those targets, then all of that money is sent back to whoever sent the original payments, right? And so Kickstarter is a middleman, which is basically, you know, providing that service. But now you can implement that kind of a service in a smart contract, and the smart contract takes care of the logic that says, hey, you know, if we reach the 1 million target within a month, then send the funds to, you know, the person doing the project. Otherwise, return all the money back to the people who sent it. So now you don't need, you know, a middleman to do that. It automatically is done by the smart contract. You know, in the real estate world, I'm sure you're very familiar with like escrow companies, right? And
Yes.
so what's the job of an escrow company? Basically,
Middleman.
yeah, they're a middleman. On the one hand, you know, they take the deed from the seller. On the other hand, they take the money from the buyer. And once they've received both of those, they do the swap and basically, you know, exchange between the two parties. And then, you know, the two parties are happy. Now, why do they need that middleman? Is because the two parties don't trust each other. You know, the person with the deed doesn't want to hand over the deed, you know, and trust the buyer is going to hand over the money, right? And vice versa. The buyer doesn't want to hand over the money first. And so, you know, you can actually create an escrow contract on something like Ethereum, and it'll be a smart contract which says, okay, wait until the two parties have sent in their assets, and once both assets have been received, send, you know, asset A to party B and send asset B to party A, and it's done, right? So yeah, so once, you know, once real estate has been tokenized, like using NFTs,
Yes.
we'll be able to make these kind of smart contracts and have these, as you know, escrow services live on a blockchain.
So basically no lengthy contracts, you know, that most of the people don't even read it, right? And
yeah, I
don't
mean,
even
at the end
understand
of the
that.
day,
Yeah.
it just has things like, okay, well, you need to turn in your deed by this time, and the seller has to, come up with the money by this time, and those kind of things. And so you can program all of those parameters into a smart contract, right? I mean, if you look at a real physical contract, it's basically the same boilerplate, but then it has the blank spaces for like, who are the two parties, what are the dates, what are the amounts, things like that, right? So you can just program all those parameters into a smart contract, and voila, you don't need a middleman.
So if I say in a simple language, the smart contracts, they store rules or instructions and verify them and then self-execute them. So basically you're taking me back into the programming language when we started very initially, like the basic language kind of thing,
Yeah, yeah.
create the
So
rules, store the rules and execute it, right?
yeah,
For
exactly,
the
exactly.
procedural language, or today's word, if we can say the object oriented, because in the object, the whole information is stored and gets executed, but there you need to do something in order to execute that. Wow,
Yep,
that's interesting.
exactly.
Wow. It's gonna
Yeah, yeah.
eliminate so many things with this smart contracts in place. But let me ask you this question. So you mentioned one problem that smart contracts solve is the trust, right? Because the reason we have the intermediaries because the parties don't trust each other, two parties. So what are the problems smart contracts solve?
Oh, wow. It's pretty much up to our imagination, right? To come up with how do we want to use these smart contracts to solve tons of different problems. So like if you look at what's happening right now, like with the applications that have been built on the Ethereum network, smart contracts have been used to create like decentralized exchanges. Prior to this innovation, people would always have to send their coins or tokens to the exchange, and the exchange would be like a central trusted middleman who held on to those coins or tokens for you and allowed you to do the trade with other people on that exchange. And then later on, if you converted your coins into something else, then you would withdraw the other coins, right? Now, with these decentralized exchanges, you can just, use a smart contract where the coins you send in go into one bucket, and then the coins that you want come out of a different bucket, and it's just handled by the smart contract, and so you don't have to trust anybody ever with holding on to your coins or tokens. So that's one example. Other things that have been created are things like stable coins, which are backed by collateral like Ethereum. And so Ethereum is volatile in the sense that the price of Ethereum goes up and down a lot. But if you want a stable coin that's pegged to $1, or you could make one that's pegged to gold, or even pegged to some other stock, whatever you want to peg it to. But usually people like to peg it to something that's stable. You can actually have collateralized stable coin where people are, putting in, like, let's say Ethereum into the smart contract. And when you add, like, let's say $2,000 worth of Ethereum, you can mint $1,000 worth of this stable coin. And now, you can exchange that stable coin with other people. Anybody that receives it is guaranteed that this will maintain its, dollar peg. And if the price of Ethereum, say, starts dropping, and you're no longer, have $2,000 worth of, Ethereum, but you've already pulled out $1,000 worth of a stable coin, well, you have two options. You can return back some of that stable coin back to the contract, and the contract will just, burn it. or you can add more collateral, right? You could add more Ethereum to the contract and then get your ratio back up. So in that way, these stable coins are very solid. You don't have to trust, sometimes you have these stable coins that are like pegged to the dollar, but then the issuer says, hey, we have dollars in the bank to back up these, tokens that we've pegged to the dollar. So just kind of believe us, right? But if they don't really have that, then, these really aren't pegged to the dollar. So you don't have to trust a central party like that to do it. You can have a smart contract do it, right? So that's a very innovative use of a smart contract. They're also using smart contracts for lending and borrowing. They're also using smart contracts for doing prediction markets. So people can put up a question which can, have a definite answer by a certain date. For example, somebody, like when the elections were happening, somebody could put up a question like, hey, is Joe Biden going to win the presidency? And then people can, buy or sell shares of either saying he's going to win the presidency or saying that he's not going to win the presidency. And, if you're right about it, then you have a good opportunity to gain some money by, doing that. And so now you have these prediction markets, which work really well and help predict things before they actually happen. So yeah, lots of very interesting things that can be created with smart contracts. And
Yeah,
I think we haven't even seen, what's going to be created in the future. And there's a lot of, young, bright kids coming up with really interesting ideas for what
that's
to
true.
build.
But you mentioned one thing really good, the elections, right? So
Mhm.
what they do, the elections, they put that on the blockchain. What is going to look like? Can you tell us that about a little bit?
Yeah. So we can actually even one day do voting on the
Uh-huh.
blockchain. So a prerequisite for that is that we need to have some sort of identity system on the blockchain
Mhm.
where, we can ensure that one person can't create more than one account in this system. And then once we have something like that, then, we can start to think about actually having voting on the blockchain. I don't know how far we are from, achieving that prerequisite, which is, the identity system. But there are a lot of projects working on blockchain-based identity, including our team. We have future plans to use Sharding to create a project called Globalville, which will allow you to have the guarantee that each person has like one primary account in Globalville, and that the one person hasn't created multiple accounts, and it also guarantees that every account, every primary account in the system actually has a real human attached to it. So yeah, we're also working on that problem as well.
Yeah, and once that's implemented, it's gonna mitigate so many issues, and it's gonna be one ID,
Oh
one
yeah,
person. It's kind of a global, international kind of thing. You do not need to do anything. Do not need the passports even, because all the information should be stored in one block for one person, including your medical records and everything. So
right. Yeah,
yeah,
and once you have those identity-based systems, you can start adding more and more data to
exactly.
those accounts, right? So you can get your medical records in there. You could get your credit, history,
Passports.
into that,
Yeah,
your passports, all kinds of stuff. Your certificates, like let's say you completed a college
right.
degree,
Mhm.
all these things could be attached to your account
One
and
identity.
thereby allowing others to validate it, right? Like, I mean, if you think Vinky. I mean, in the current world that we're living in, if I pull out and show you my driver's license, how do you verify, you as an individual, how do you verify that this is even a valid driver's license, right?
That's true.
Only the DMV or, somebody that has access to that database that contains all the driver's licenses can actually type in my license number and then bring up a record that maybe shows my face. And then you can, verify that, hey, this person looks like the same person in this, database. But the rest of us are kind of left, outside of that system, right? So imagine, if you're trying to rent your property and a tenant comes to you, and of course, you look at their driver's license, and yeah, all you do is, you say, oh, well, the person looks like the same person on this driver's license, but how do you know that driver's license is legitimate and not fake, right? And made up? We don't. There's no way to verify that. But in the future, you'll be able to take your phone and, scan like the code on that license and then check it against the blockchain.
Right.
And then the blockchain can show you, in your app, what this person is supposed to look like. And then you can verify, hey, does this person really look like what the blockchain says that they're supposed to look like, right? So that will allow everybody to have access to this database where we can all, use it for, doing identity verification.
So, but what is the probability of the identity theft in that case, or tampering the block that has all the information?
Yeah, so in that kind of a world, I think it's completely impossible to do identity theft. Because identity theft basically, right now, like our world is so fragile. Identity theft basically means that if I got enough information about somebody, like, suppose some, hacker got your social security number. Let's say he even found out, found a copy of your passport. Now he knows your name, your date of birth, all this information. Well, they can go and log in and create accounts on different databases, right? Like, for example, he could open up a bank account as you, especially an online bank account where you don't have to show up in person. You just need to, like, maybe, upload your passport, right? And, maybe your driver's license information, things like that. So that person can provide to a bank all this fake information, and the bank will go ahead and create the account. But in the future, if we have an identity system, the bank can actually check the blockchain to make sure that the identity information that you provided is really legitimate, right? And so that'll prevent any kind of identity theft.
So basically, it's gonna be one huge database for everybody to access it.
Ultimately, that would be awesome if we could get, like a global level database where every person has, their own identity record on there. And then, but that doesn't mean that all your information is open to everybody. It's only available to the person you shared it with, right? So, and then you can also have like time limits on how long they can see that data and so forth. But yeah, like, if we get into a world like that, that would be amazing. And in that kind of a world, then even governments don't have to worry about having to issue their own identity cards, because now they can also use the blockchain to validate the identities of everybody, right? Like when somebody moves from one country to another, they basically end up having to go through this whole circus of getting a new identity created in that new country. Now imagine if all the countries were using a global identity system,
Mhm.
you could move from one country to another, and wherever you go, the authorities could just scan your QR code and check the blockchain to know who you are, where you came from, whatever other information you wanted to share with them. So yeah, it's going to be a very different world, which, when we come back and look at how things are nowadays, we'll be like, oh my God, how did, people get by, just like, if I think about, 10, 20 years ago, if I was driving somewhere and I have no cell phone with me and no GPS, map system to be able to route me to where I need to go, I just have a hard time thinking like, oh my God, how am I going to get there, right? I'm just like driving without knowing where I'm going. And you remember those days, we
Yes, I do.
stop at the local gas, the gas
ask for
stations
the
over there and
directions.
ask the person, or
Mhm.
buy a map from the gas stations. Gas stations don't even sell maps anymore.
That's
But
true. Yeah, I
so
remember
so
going
now we
to.
can look at that world and say, my goodness, how did people get by,
Right,
during
right.
that time? Yeah. And so that's how, we're going to look at this current world that we're in, maybe 10, 20 years in the future, when we have, something like a global identity system. And we say, my goodness, how did we get by without these kind of networks?
Technologically, we are growing exponentially. And then all the laws and regulations, they lag behind. So what kind of laws or legislations they're going to come up with around this whole concept?
If, things become more democratized, you can imagine a world where we may not even need to have elected representatives, right? Like, so
That's
for
true. That's right.
example, yeah, so imagine, we have a system where we can now do voting on a blockchain because
Right.
we have identity on the blockchain. You could imagine a world where, so all these different issues get proposed by people, the issues get vetted, through some sort of a upvote, downvote kind of a system. And then the issues that, reach certain thresholds, then they actually go to a second stage where everybody can vote on it. And if you care about the issue, you would go and vote on it, right? If you don't care about an issue, it doesn't matter to you.
Right.
And so now you have the people that are really, involved with the issue, making a decision on it, right? Um, like, do we want to have this highway pass through this neighborhood? Well, that's an issue that only the people, in that area really need to decide, right? I mean, or can contribute to. Um, and those people in that area, they might vote no for it, and you don't get it. But okay, so one might say, well, if that highway had been developed, then lots of people all around the country could have used it, right? Well, maybe we're not incentivizing the people that live there enough to, sell their properties and
Right.
allow this project to happen, right?
Mhm.
So, I think, I think it's very important to have the people that are involved in the issues be the ones that vote on it, and not just, some elected representative who may not even
Planning the future.
have the same issues that you're thinking about deciding on your behalf. And so we can have a world where many more issues can come up, many more people are involved in deciding on those issues, many more people involved in, like, the legislation that's being written and so forth. So I think that would really make the world a better place. And yeah, I mean, there's still a need for governments. You do need governments to kind of orchestrate communities at various different levels, and provide services to those communities, right? Like if you really think about what's really important that a government does for you, it's basically, providing you protection, providing you actual services in terms
Right.
of, like maybe garbage collection or fixing the roads and bridges and things like that. But yeah, and so those are the kind of things that you really want to fund governments for, and not really fund them for, doing things like bailouts of large corporations. I mean, yeah,
Yeah. But the thing is, they have a justification for everything, right? We say bail out
sure.
this organization. They'll say, yeah, we are trying to stabilize the economy, and which you will agree to, being a common man. But I think that perspective, or when most things are moved to blockchain, or blockchain is implemented at a larger scale, the thing's gonna shift.
Right.
And the thing's gonna be looked at a little bit differently. It's not like saying that eliminating the government or eliminating the police or eliminating everything in the picture. They're still gonna be there, but the role play is gonna be different than what we see in today's world.
Yeah, and the thing is, it's like a lot of times people always look at these things kind of in a negative way. Like if you think about, like eliminating paper maps. At that time, there were companies making paper maps, right? And it would really hurt their business model, right? And so almost any innovation is going to have its winners and losers.
That's
right?
true. That's true.
And so, if you just are kind of old school and you don't want to budge and you don't want to move with the technology, you don't want to see like, how can I use this technology to make things better and make the best of it, you're going to get left behind, right? So like if I had a map making company in those days, and if it was making a lot of money, I shouldn't just like keep milking that cash cow. I should think about maybe investing some of that into telecom companies, right?
Exactly. Yeah.
So that's the way to do it, right? And so,
Yeah.
so that's, yeah. So basically, there's going to be winners and losers with every technological shift that
That's true.
happens. And even, the way governments are done, they might change over time. We're able to have the kind of governments that we do now because of a lot of technological advantages that we've, accumulated over time, right? Otherwise, if we didn't have this, we might still be back in the days of, kings and queens.
That's true.
Right. So, yeah, really, I mean.
So next time, let's talk about cryptocurrencies now, because I think we touched on that a little bit in our last episode. We talked very briefly on Bitcoin. So let's talk about the basics of the cryptocurrencies and what the future is going to be when there is all cryptocurrency. There is no fiat anymore.
Right.
So,
yeah, I mean, that's going to be a really interesting world.
Yes.
Yeah.
Thank you so much for today's episode. I'll see you next time very soon.
All right. Take care.